everyone. Today we're going to continue our conversation on our functions and their graphs. So first thing we're going to talk about, we're actually going to look more at graphs for this lesson, for the B part of functions and graphs. So when it comes to a function, we know that not every graph that we see in the rectangular coordinate system is the graph of a function. So when we're talking about the rectangular coordinate system, we're talking about like when we draw our XY coordinate plane, right? So every graph that we draw on this perfectly drawn coordinate system isn't necessarily always going to be a function. And that observation leads us to this thing that we call the vertical line test. So under the vertical line test, we know that when it comes to a function, no value of x can be paired with two or more y values, or two or more different y values. So when it comes to graphs, we can look to sit there and see if there's x has more than one. So if we look at something simple like a line, and we want to do this vertical line test, vertical would be going up and down. So we're going to arbitrarily draw lines going through. And I touched my graph one time. And I go through and I touch my graph one time. So no matter where I draw a vertical line, and granted this line goes forever, so I can draw it out here. Anytime I draw that vertical line, I'm only going to hit my graph once. And if I hit my graph once, that means that there was only one y value for every one of those x's. So I can use that vertical line test and ask myself the question, is this a function? And I can say, yes, it is. So let's try, let's say, here's our x and y coordinate plane. Let's say we had a graph that looked like this. Okay. So I'm going to go through and do my vertical line test. And when I go through right here, I'm actually only going to hit it once. So we're like, ho, 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 this might be a function. But when I draw a vertical line over here, guess what happens? I cross here and I cross here. So that's telling me for, let me change colors. For whatever like my x value is right here, like technically I have this y value, and if I go this way, I have this y value, right? So I have two y values for this x value. And I can't have more than one y value. So it fails the vertical line test. So when I ask myself again, is this one a function? I have to say no, because it fails the vertical line test. I got a little bit of room here. Let's say we draw one that looks like this. We go through. I hit it once, I'm hitting it once, I'm hitting it once, I'm going through it once, I'm going through it once. No matter where I draw that vertical line, I'm only going through that graph once. So is it a function? Yes, it's a function. If I have my XY coordinate plane and I graph, this is my graph. It's a beautifully drawn circle. It's perfect in my eyes. Is this one a function? What do you think? Take a moment, think about it, come up with a rational reason why you think either yes or no. Right, I'm going to say the same thing you guys said. Nope, it's not a function. A circle is not a function because when I go through, at this point, I'm going to hit it. When I go through there, I'm going to hit the graph twice. Granted, I might go through here and only hit it once, but it has to pass the vertical line test at any point, and there are numerous places where I'm touching it twice. So that's how we look at graphs, and we can determine if it is a function or not. So now we can look at a function and look Ha 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 ha, I beat us to it. I knew that while being recorded live, I would probably struggle with trying to draw this, and let me tell you, I struggled anyways. So I went ahead and drew this nice little quadratic, this little parabola for you guys. So that way we can go through and answer some questions about this cute little parabola. So when it comes to our functions, we're going to talk about domain, we're going to talk about range, x-intercepts, and y-intercepts, and evaluate, which is a lot of the stuff that we've been doing last section and this section. So let's start off with the domain. So domain, I'm referring to my x values. And when I look at my parabola, I got my little arrows here telling me that this graph is going to go on forever. So I want to see if I can find my smallest x value. So as I go through this graph, I'm going to keep going and going and going and going and going. So my x values, like I have a graph, right? My graph is here at this x value. At this x value, it's here. At this x value, it's up here. At this x value, it's going to be up here. So as I keep going to the left, because technically my parabola is going to continue to go to the left, it's going to go to the left until it gets to where? Yeah, it's going to go to the left until it gets to negative infinity. So when it comes to my domain, I know I'm going to go all the way to negative infinity. And when I go to the right, I'm going to keep going this way, and I'm going to keep going and going and going and going and going and going and going, and it's going to get farther out and farther out and farther out, and it's going to continue to go until it gets to infinity. Beautiful infinity symbols, right? So now we just need to look at our notation for this. So when we're talking about domain and we're going from negative infinity to positive infinity, we're going to put these parentheses around them. And when it comes to some notation, when it comes to putting a parentheses around something, it means that it can get close to, but it can't be. Because if we're talking about infinity, we can get really, 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 really close to infinity. But once we think that we're at infinity, guess what we can do? Just like Buzz did, we can go beyond it. So once we get to infinity, we can go a little bit more, and then we're at what we think is infinity until we go a little bit more. So we can keep getting closer and closer to infinity, but we're never going to reach infinity. If it's a number that we can equal, instead of doing the parentheses, we do a bracket. And a bracket means that it can equal. Okay. Another way we can write domain is we can use our inequalities. So if we're talking about domain, I'm going to throw a little bracket around here and say that we're talking about our x values. And on my x values, I knew that my smallest x value was negative infinity. And so negative infinity is going to be less than our x value. And our x value is going to be less than infinity. And then we're going to throw a little bracket around those. Right? So you'll see it either way. And if you continue on to calculus, calculus likes to write it this way. Right? If once we finish up with range, domain, we can talk about our range. And our range are our y values. Right? So when I look at my graph, I want to try and find the lowest y value I have. So if I think of this number, does my graph have a y value at, what am I at, 1, 2, 3, 4? At 4? Yeah. I'm here at y equals 4, and I'm here at y equals 4. Does my graph do I have a graph at y equals 0? Yep. I'm here at y equals 0, and I'm here at y equals 0. So I'm going to keep going down until I can find that smallest number. If I got way down here, like, do I have a graph anywhere that's touching that y value? Nope. So do I have one here? Yep, I got one there, and I got one there. I can keep going a little farther down. What about right here at, what am I at? 1, 2, 3, 4. At negative 4? Yep, I'm at -4, and I'm not going any lower than y equals -4. So I know that my smallest y value is going to be -4. Now I'm just asking myself, can I put a parentheses or a bracket around it? Well, at -4, I have a point there at -4, so I can be -4. So I'm going to put a bracket around it. Now I want to find my biggest y value. So I'm going to do that same thought process, but now I'm going up because I'm trying to find my biggest. So I'm like, here, do I have a y value? Yep, I got one here, and I got one here. I go up to, do I have a y value here? Yep, it's over here, and it's over here. And I'm going to keep going up, and because my parabola continues to go up, and it goes to infinity, my largest y value is now going to be infinity. I really need to work on those little infinity symbols. Some days are good days, other days are bad days. Sorry, guys. Can I be infinity? Nope, I can only get really close to infinity. All right. So we got domain, we got range. So now let's talk about X-Intercept. And then we'll talk about Y-Intercept next. So X-Intercept is when I'm looking for the values in which I cross the X-axis. So here's my fancy X-axis. So where does my function or my graph cross it? I cross it here and I cross it here. So I crossed it at -3 and 1. So for my intercepts, I'm going to have -3 and I'm going to have 1. And then I can talk about Y-intercept. Y-intercept would be where I'm crossing the Y-axis. So I'm going to go through and I'm going to see where do I cross. And I cross right here. And watch, I'm going to even cheat a little bit, right? We're going to make it a little bit more, just to... So where am I crossing the Y-intercept? I'm crossing right here. And where is that at? -1, -2, -3. So I cross the Y-axis at, oop, I don't want, trying to keep my colors consistent, -3. All right, one more thing. Let's do a little evaluaciones. So if I give you f of -2, because this is function notation, normally we would write that as like f of x, right? F of -2. Trying to be a little neater here. So f of -2 is saying this is my input, right? So if my input is -2, I need to find my output. Inputs are x, outputs are, yep, y. Good job. So I'm going to find when x is -2, what is my y value? So on my graph, I'm going to go back 1, 2. Whoops. Yes, sorry. -1, -2. And here's the point. So I'm looking for this point right here, right? So what's my y value at this point on my graph? My y value is -3. So when x is -2, y is -3. The other way we can evaluate these is we can say that f of x equals, let's go with 5. So again, when it comes to function notation, this is my input, this is my output, this is my x, this is my y. So if they're asking you to evaluate f of x when it equals 5, it's saying so when the output is 5, what is the x values? So we're doing it just in the opposite order as what we did this one. So now I'm looking for when my y is 5, I need to find my x values. So when my y is 5, So 1, 2, 3, 4, 5. So here's when y is 5. So I'm going to look at my graph. And where am I at 5? I'm at 5 here, right? And I'm at 5 right here. So I just need to find those two x values. So what am I here? Right there. What is that going to be? Negative 1, 2, 3, 4. So when x equals negative 4, where was I? 1, 2, 3, 4, 5, right? So then I'm looking for this point, and that would be when x is 1, 2, 3, right? And then when x is 3. So we just need to make sure that we understand the different notations. Do a little scribbly here. So this was, right, f of negative 2 equals, and we're finding our output, right? We're finding that y value. Where on this one, when they said f of x equals 5, well, we're looking for what the x value is. So I gave you guys a couple problems to work on for today. Head on over to the website, and I'll talk to you later. Bye.